Hey, so how many times have you lost files or images that you saved in your computer because you don't remember their names? Happens many times, right? What if you could search for the meaning of the document or the contents of the images without ever having to organize them or use a specific naming convention? Well, hello there. My name is Omkar, and today I'm excited to walk you through Gnosis, a simple search pipeline for unstructured data that I built from ground up, trying to achieve somewhere near enterprise style. So this is my latest project. At its core, Gnosis it is a semantic search engine for unstructured files. So what this search engine does is instead of relying on the file name, it actually understands the content, whether it is an image, a document, a presentation, and it lets you retrieve it using a natural language, or you can say a prompt in simple words. For example, you can search for an image where a man is wearing a white shirt in front of a black car, and it will retrieve the relevant file, even if the file name is something meaningless like IMG 2026 2020 blah blah blah. I mean, that's how the file names are when you transfer them from your mobile or camera to your computer. So let's start with how you actually run this. So as you can see here, the entire system is Dockerized, and only one simple command, that is Docker build up, and you will have everything set up in your Docker. A fast API server, a PostgreSQL, a quadrant vector database, Apache Airflow, Redis, which is necessary for Airflow, all of it running locally, and there won't be any setup headache or something later on. So the Airflow workers are configured with Celery executor. So basically, Airflow can be run in different types. Uh, Two of them are Celery executor, and another one is local executor. So Celery executor, it actually uses multiple, as you can see, it actually uses multiple containers, that is multiple systems. So Airflow here is distributed across multiple system. In local executor, Airflow runs in a single system. So I wanted to use Celery executor because I wanted to learn something new, something or somewhere where I would understand how a application is running across a distributed system. So, anyways, yeah, so as you can see here, I have config.yaml open. Everything is tunable through this like config file. If I want to change my embedding model, if I want to change my image LLM, if I want to change anything, any value related to the LLM, or chunking size, or even batch processing, or else let's say like right now my system has NVIDIA GPU in it, so I can use CUDA as my device. But tomorrow, if I were to switch on some low end device which has only CPU, I can switch it from here itself. So this might not seem a huge thing, but it took me a lot of time to actually refactor all my files into one config YAML, and it actually helped me a lot in iterating stuff. So, anyways, now coming to the project itself, you can pause and see this, read this whole infographic. Until then, yeah. So, yeah, the entry point is our fast API layer. When we navigate to localhost 8000, you will get a clean web UI where you can log in, drag and drop files. The files which I am supporting through Gnosis right now are PDFs, Word document, PowerPoints, plain text, or images. So our API layer also validates the MIME type and saves it to the directory. Saves it to which directory, uploads every, as you can see, like I have a mounted directory here. So this mounted directory actually acts as a bridge between API layer and pipeline layer. So our Airflow has file scanner DAG where we'll get later. So as of now, let us access this localhost 8000 in my system right now. So as you can see here, I have a simple login. Well, this login is currently, like, being very honest, not very necessary in the current system, but later I'll be adding files for a particular user. Right now it is in a single system, so I'm like retrieving files through it for every user. But later, while upscaling this, let's say in future, if I'm deploying this or something, at that time I would use it properly. So I'll log in right away here. Um, there we go. So in our API layer, as you can see, we have three tabs: upload, search, and about. Out of which upload and search are necessary for our workflow. So All the file types which are supported by upload, you can see them here. So this is my Airflow UI. Let's get here later. And here's my GitHub link, which I'll be attaching in the description. So um, yeah, this is our API layer, and from here we'll be uploading files, and whatever files we upload will be sent to a directory, and that directory is actually mounted. So what is mounting and all? Well, that's basic Linux principles that you need to know. So let's go and drop a file here. Wait, before dropping a file here, let me just pause my file scanner. Mm, documents, pictures. So yeah, as you can see here, we have an image. This is an image of a person who's standing in front of a car. We'll upload this. As you can see, the file upload is successful. Now we can see that file in our data directory of our application. But right now, if I go to search and if I search for something like a man standing in front of a black car, search. Well, this is not this is uploaded, but this is not like we are not able to see it on the search layer yet. So why is that so? Well, because our DAG has not processed it yet. So we'll start up our file scanner DAG here. We'll trigger it manually. How this DAG works, what is a DAG and all, we'll get through it soon. But let me just complete this demo ASAP so you can see how this application actually works in one go. Let's refresh. Okay, this is processing. Okay. Please check that Olama is downloaded. Right. I forgot to start up my Olama. Let me check if Olama is running ASAP. We can go to the Olama endpoint, which is localhost 11434. Okay. Apparently, it's not running. Olama serve. We have started up the Olama. Now the Olama is running. And if we just restart this tag, it should be working now. Hmm. Yeah, so our file is processing. Until our file processes, let me get back to the system. So the backend here, as you might have seen here, is conceptually similar to an ETL pipeline that we use in data engineering. These days, I'm into data engineering a lot, and this is a project which I'm using to learn and demonstrate Airflow and basics of ETL. So talking about our Airflow layer, these are all the containers which are attached to our Airflow layer, and these are all running on localhost 8085 in my current setup. So our Airflow has three DAGs: file scanner DAG, document processor DAG, and image processor DAG. So yeah, now I have say maybe I said a lot of terms which many of you might not be familiar about. So our backend, as I mentioned, it is conceptually similar to an ETL pipeline. ETL pipeline is basically ETL stands for extract, transform, and loading. It is a procedure that we use in data engineering to extract the data from the source, transform, and process it so that our stakeholders can use it properly. I might not say that this is 100% similar, it is an 100% ETL because we are not loading in some data warehouse or something. We are loading our, that is our OLAP. OLAP is somewhere where you load the data after processing it. So we are loading it into our quadrant database. So yeah, talking about the Airflow again, we have three DAGs: file scanner, document processor, and image processor. Our file scanner DAG, well, let's see what this does. So as you can see, the first information about this that I wrote here is it replaced watcher.py. So in my previous version where I did not have Airflow, I was actually using a file watcher based approach, which used Python's watchdog library, and it basically triggered events whenever the changes were made in the directory. But it did not scale well because I had to keep it open or keep it on all the time, and it would read the changes only when it is on. So that is not something that we might use in production. So that's where I introduced Airflow in, and again, like it had many tightly coupled functions into one single script, which is really brittle when it comes to production. So, yeah, I switched to Airflow. Airflow allows me to introduce proper orchestration, fault tolerance, and more visibility for upstream and downstream of each task and function. Now, what is upstream of data and downstream of data? Upstream is I'm sorry. A stream of data is the stream from which the data arrives to you as a data engineer or as an ETL engineer. And downstream is where you supply the data or load the data to stakeholders. So yeah, the ingestion pipeline, as you can see here, it begins with our file scanner DAG. This periodically scans the data directory and validates the incoming file, and the file validate and then registers them into the PostgreSQL. PostgreSQL is basically something similar to OLTP in my current setup. So this stage, it includes validation. So why validation? Coming from a bit of a cybersecurity background, I do understand that such systems can be broken easily when it comes to the security aspect. So file validation is important. Here, currently, I have used MIME validation, first one, and second one is like the symlink check. So there won't be any symlink attacks or there won't be any MIME attacks on my particular system. So here's about the validation part. Then whatever the valid documents that we get from file validation are inserted into the, as you can see, the Postgres database, and if it is an image, it is inserted into the metadata. Now, whatever file validation, like whatever valid files are, if there are some there are some particular documents in it, then it will emit the new document asset, and if there are images, it will emit the new images asset. Now, what is this document and images asset? I have used them to trigger my downstream DAGs, which is document and image processor. So I would not be, as I'm running this every minute, so there must be idempotency maintained, and you can see that on conflict do nothing. So basically, I have also given a thought into that as well. So the idempotency is maintained, and again the processing power is not wasted. That is, we do not process each and every file every time the file scanner runs, right? So basically, what is happening, in simple words, is this file scanner DAG, it is running every minute, and if it runs every minute, it checks for each and every file every minute, and we do not want duplicates in our database. Let it be Postgres, let it be vector DB. So we do not want duplicates there. And again, if we would process each and every file, a lot of processing power would be wasted there. So that's where the term idempotency comes in. Anyways, moving next. These assets are basically the event triggers, and then these assets trigger document processor and image processor tag. So currently, this file scanner DAG, as you can see here, it runs every minute. So in future, I'm thinking to change it into an event driven DAG. That is, maybe if I shift to cloud, I would use Lambda functions or something. Or else currently, I think Airflow also supports it. Call the DAG through a particular function, and that function would be the file input function of the API itself. So I'm thinking to modify this step in future. So going next, finally coming to our document and image processor DAG. So these asset-based triggers, document processing DAG and image processing DAG, these extract data, chunk it, embed it, and store it into the quadrant database for documents. For document processing specifically, I have used file format extractors to pass text from PDF documents or presentations or text files. And for image processing, I'm using, as you can see here, a lightweight VLM, which is Mini CPM 3. It generates structured description of my images. Additionally, I'm also extracting the EXIF data, and I'm appending it to whatever like the text is extracted from mini CPMV. So in simple words, what I'm doing here is I'm extracting the text out of my files. Let it be documents, let it be images. Now, if it is a document, I'm using Python based libraries to extract the text out of those particular documents. And if it is an image, then I'm extracting it through the VLM. So currently, this VLM is something that takes time as I'm running it on a local setup. And well, it takes time, meaning it does not take very long, like around 5 to 10 seconds at max. But still, for scaling, this is not good, and I do understand that. And later in future version, I might go with OCR for scaling up properly. So whatever the text is extracted through the document processor and image processor DAG, it is chunked into segments, and then the file chunking part and the embedding part comes in. Well, I want to explain this properly. So the text which comes from the, what do you say, these two tags, it basically is chunked into overlapping chunks. The chunk size is of 400 word, overlap is of 100 word, and the step I'm using is of 300 words. I do understand that using words is not really good. Like I did it for simplicity initially while setting this up, and later completely forgot it to turn it into tokens. So um, I do understand that, and later I'll be switching to tokens soon. And currently, I'm using fixed size chunking for performance because I'm running it locally, and there are already so many performance heads that I have here, and I just want to have some mercy on my laptop. So whatever the embeddings are, those are generated using BG and BG small model. Well, it is a small model of having around 364 dimensions, I guess, which is fine for me as of now on my small scale. And then I'm normalizing it. Normalizing basically turns our search faster and cleaner in simple terms. So after normalization of our embeddings, we'll store them in our quadrant database. So this is running on localhost 6333. So then comes the search layer. Now let's get back to our Gnosis and search for a man standing in front of a car. A man wearing a white jacket. Let's search. As you can see, the image 2026 blah 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 has successfully appeared in our search results. So now let us understand how this search layer works. So whenever you type a query, which is this query, it gets embedded using the same model, BG model, and same normalization is all like that also happens here, and it produces a single vector. This single vector, as you can see, this single vector, it goes to the quadrant, and in the searching algorithm part, it goes to quadrant, and again cosine similarity search is used here. Currently, I'm using dense searching only. Like in future, I will be integrating keyword based searching because again, like dense searching returns you good semantic results. That's okay, but again, I want if I want to add more weight on the keywords, I'm unable to do that right now because I'm using dense search only. In future, I'll be integrating hybrid searching, and whatever the results are, like out of this searching algorithm, it will actually return the similar chunks along with their scores, and all those chunks, all of them are sorted along with their score, and the best chunk for the best file is extracted, and it is shown in a list here. Where did that go? Yeah, right here. So yeah, the results come to front end as file name, file type, and similarity score, as you can see here. So this is my file name, and as you can see, the file type is image. I have added an emoji here. So instead of this particular thing, let us test with our other document from our data. So let us open. So MAD basically means mobile application development. I use those PPTs and PDFs. These are actually from my college syllabus, mobile application development. And yeah, as you can see, all of my syllabus PPTs also appear here. So yeah, that's it about my current project. So along with this, I'll be implementing, like, along with this and this and this and this, I'll be implementing a lot more optimization and changes and modifications and technologies into my project, as currently I'm learning data engineering. Like, this is a really really interesting thing for me as of now. So I'll be implementing all of this into my project. So, and obviously I'll be showcasing that on my LinkedIn and my GitHub as well. So stay tuned. If you like this project, please, please, please make a star on my GitHub. This is my GitHub repo. All of the the README is also present. If you want to install it on your own computer and run it, of course you can. It is really simple. And if you find any problem, you can also contact me. So yeah, all of this runs on your local machine, so it won't hurt to check it and run it, right? So clone the repo, run one Docker command, and you will have whole working semantic search engine. So yeah, that's it from my side.